Hey guys, Harmony Vertical Axis Wind Turbine coming at you. So, I have my new servo motor installed, and after talking to the guys at Technic, I am ordering the next size up because this one is just a tiny bit undersized. So I keep hitting the torque limit on it. This is a big heavy machine, and the one that I ordered was just on the edge. It works fine. It's just a tiny bit underpowered, and that was my fault. It's certainly not the servo's fault. Miscalculated how much weight was really here. So, guess what I have in my hand? You guys have been waiting patiently watching videos of me doing all this crazy CNC stuff, but I got my $10,000 grant from Ben Franklin Technology Institute, and that was to help me get my prototype finished. And you're thinking, well, holy cow, why did you take so long and do all this other crap? Well, I could have taken that $10,000 and bought maybe one set, even two sets of parts for the wind turbine. But if I messed up, if I didn't calculate something right, and then I needed new parts, now what? I've just blown all of my money on getting parts. I'm not that kind of guy. I decided I was going to finally get this machine working the way it's supposed to work, with X, Y, and Z, so that I could make the parts for literally 1/50th of the cost of getting them manufactured. What that means, I take a couple $1,000s, get the tooling I need, get the pieces, get the parts, get all of the peripheral items, get this machine fixed up, and still have like $3,000–4,000 left over to buy raw material. That's what I'm holding in my hand. I bought 12 feet of this stuff. This is the support plates that's going to go in each of the wind turbine scoops, below and above the scoops, to hold them steady. The really cool thing is I've mapped out the machine paths to do the machining of these parts right here for free. I mean, okay, I pay the electricity, but soon when I have my wind turbine going, that'll even be free. So, what you're looking at here is a little test piece, just a piece of scrap that I have in here, and I'm going to test the very first cut. I know there's a hole in there already, but that was from before when I was doing other stuff. Just to see how the mill acts the very first time that I ever do a full X, Y, and Z milling operation. I may break this milling bit, I may not have the feed and speed right, who knows. There could be a whole bunch of things that go wrong, but we're going to tape it and we're going to show what happens.
So I should stand really far away.
Yeah, you should stand. No, it'll be fine.
Okay.
Once I run a few tests and get a good feel for where this is at and how the machine's dialed in, I'm going to graduate up to the next, test piece, because this was just some leftover. See how I cut through the full 3/8 material. This is just little 1/8 material. It's U-channel. Then finally I'll put my first piece in. I've got like 10 of these guys, 12 of these guys, I don't remember, over there on my pile. I only need 6 of them. I think I have 10 over there. So I even can, allow myself to make a few mistakes. It cost me $60 for all the stock that I have to make 10 or 12 of these parts, however many I have over there. So I can mess up repeatedly if I screw something up, if I get something wrong, and I can make new ones for practically nothing, $60–70 a pop, rather than spending $2,000 or $3,000 to have some parts machined or water jetted at a facility, and then I'm just stuck with whatever I ordered. I like to get my hands dirty. I like to do my own work. I like to learn, so that's what we're going to do. We're going to take it for a test drive. The very first time, I'm bringing you along with me. We're going to see how this machines. So, I've got it clamped up. I've got literally just the very first hole that I'm going to allow the machine to do. Just one hole. That's it. I just want to see if it climbs into that hole or spirals down into that hole properly using X, Y, and Z. I've never before run my machine machining anything with X, Y, and Z. So you're about to see that. I'm even using a crappy 4-flute end mill, which you're supposed to use 2-flute or 3-flute when you're doing aluminum, but I'm just doing the initial test with a junky end mill, and I'm gonna extend my spindle the whole way down so that I can provide maximum protection to my machine if something goes wrong. So the coolant's starting to flow at this point.
Backing away. I'm backing away.
At this point, we're going to tell the machine to go. And here we go. I'm holding this down. I'm not going to move it anywhere. I'm just providing a very quick relief in case something happens. I don't even have anything backing this piece up underneath, so the bottom of the hole is going to cut out a little bit ugly. There it is, folks. Now it should pull itself out of this hole without me moving it. This would be cutting through 3/8 material. There we go. And it would be moving on to do the second hole. I haven't moved this the entire time. I think I got a chip in my mouth. I was simulating just having the machine up in, but it's quicker for me if I see it about to do something bad. It's quicker for me to go like that than reach for the emergency stop. So there we go. We'll be cutting the second hole right now on that normal big piece. So, what we have here it's still running the program. That's fine.
Oh, yeah.
What we have here is the very, very, very first machined part. That's supposed to be a 1/2 inch hole. Has a little bit of a burr. Let me get my deburring tool. That big burr on the bottom is because I had nothing backing it up. You know, you're supposed to have a something in underneath your part. There we go. So that when it cuts through, it's into solid material. Then it wouldn't have had that nasty burr. So that should be a 1/2 inch hole. Here's a 1/2 inch drill bit. It looks good. I might have it. Oh, there we go.
Sweet.
That's it right there.
That's awesome.
This hole was drilled by a 1/2 inch bit. Just a straight plunge. That was an old test hole that I did. This hole right here is the new hole that I drilled tonight with a 5/16 end mill, and it had to go around in a circular path to cut that out. So there we are, guys. First of many, many videos to come as I start cutting and building the pieces and parts to put them together. Take care.